Okay, so what we're going to do is we're going to start off by discussing linear versus nonlinear. And so this refers back to what we did last week. So this is just kind of summarizing it, linear versus nonlinear functions. And today is the 9th. Okay, linear versus nonlinear functions. So the first thing we're going to talk about is what makes a linear function. What makes a linear function? So one of the key things that makes a linear function is that the graph is a straight line. Okay, so in order to be a linear function, when we graph it, it needs to graph as a straight line. When it's graphed as a straight line, that also means that we are going to have y equals mx plus b. So it can be written this way. So it can be written in the formula y equals mx plus b. That's a linear equation formula, and so it's also a linear function. Because it can be written as y equals mx plus b, because it's a straight line, that also means that there is a constant rate of change. And then the other thing that we didn't probably really notice before because we didn't need to is that there are no exponents. So one of the first things I can do is I can easily glance and determine, is there an exponent or not? If there's not an exponent, that means there is a chance it is linear. If there was to be an exponent, it's automatically nonlinear. So that's a really fast and easy way to take a look and determine if it's linear or not. Then we have nonlinear functions. And when we talk about a nonlinear function, the first thing we need to do is recognize that it's still a function, right? So we need to double check that it's a function, which means that each input has exactly one output. If each input has exactly one output, then we know that it can pass the vertical line test. So those two things are what makes it a function. Okay, so first we would need to identify that those are true to know that I have a function. And then this is the part that makes it nonlinear. It is not a straight line, so not a straight line. And it does not have a constant rate of change. So there's no constant rate of change. So as long as the first two hold true, it's a function. And then these things have to hold true for it to be nonlinear. Okay. As a reminder, in order to find a rate of change, we are talking about slope. So you could either use the slope formula y2 minus y1 over x2 minus x1, or we could always use jumpy arrows if we were given a table to determine whether or not it's growing at a constant rate of change. So those are the two things we're looking at when we're talking about rate of change. With that being said, we are going to now switch gears a little bit to cover a specific nonlinear function. So this one is called a quadratic function. Okay, and you briefly got to see this last week when we did the linear versus nonlinear exercise. A quadratic function is often referred to as a parabola because that's the shape that it makes, the parabola. So we're going to discuss the characteristics of a quadratic function. Okay, a quadratic function. So in order to be a quadratic function, the first thing is the graph is U-shaped. Okay, the graph is U-shaped. If it is a positive graph, so a positive graph, the U shape opens up. So notice how the, oops, sorry, I'm off the page a little bit. Notice how the gap in the U is at the top right there. That means it's opening up. That means that it's a positive quadratic function. Okay, if I was to have a negative graph, that means that my U shape opens down. That means that my U shape is opening down. Which means that this opening is going to be at the bottom. It's going to be an upside down U. You can imagine like it's almost making a letter N, if that helps. That would be a negative function. And then one of the key things to know that it is a quadratic function, so this is important prior to graphing. Like when you're looking at it, you should be able to identify the function so you know what your graph should ultimately be looking like. This is going to be a function in which the greatest power of the variable is 2. That means that you can only have something that's being squared. If you have something that's being cubed, it's not a quadratic function. If you have somewhere in there x squared or y squared, anything that's being squared, then that is the quadratic function, okay? The highest exponent can be squared. If you have a higher exponent, it's not a quadratic function. Now, this is something that you don't necessarily need for our class, but it's good to know, especially because of algebra. This is the quadratic function form, and it is y equals ax squared plus bx plus c, and a is not allowed to equal 0. So not every quadratic function is written in this format because I don't have to have a c, I don't have to have a bx. What I have to have is this here. So as long as I have a coefficient and an x squared or a variable squared, then it's a quadratic function. Okay, if I have the rest of this also, it's still a quadratic function. It's just not a have to have. So this is the quadratic form. Again, we won't be really using it, but I want to make you aware of it because it's important that you can identify something that's a quadratic. And then again, for algebra next year, that is rather important. So that is it for the notes. What I'm going to do, however, is I'm going to do the first problem on classwork. I'm going to do the first problem on classwork. So that way you can see how to go about graphing and what the expectations are as far as what we should be doing while graphing functions. This is especially important because on the last quiz, some of us lost some points due to the fact that we did not show all of our information. Okay, so this is classwork for today. Some of you have printed it, some of you have not. We'll deal with that in a minute. So I'm going to look at number 1 with you all. First off, this is a function. I want to go back to how do we identify functions. When we identify functions, every input has exactly one output, which means that all of our work in regards to functions should be organized in a function table. If you are not showing your work as a function table, then you don't have work. Does everyone hear me say that? So a lot of you lost points on the quiz because you had no function table. Okay, this is not graphing linear equations. These are functions. So we need to make sure we represent them correctly. So a function table, I would have x. I have the formula in the middle, and then I have y. This is input, this is output, this is what's happening. Now, due to the fact that these are quadratic functions, I always want to use the opposite of the numbers that I chose. That sounds kind of confusing. So I want to create like a mirror image on both sides of a middle point, kind of like symmetry. Okay, if you can imagine like folding a paper in half and having both sides match up, that's what we're trying to create. So in this case, 0 is going to be my middle, right? Most of the time 0 will be your middle. So I'm going to choose 2 negative numbers and 2 positive numbers that are the same. They're the opposite of each other with 0 in the middle. So -2, -1, 0, the opposite, +1, the opposite, +2. So here and here, these are our opposites, these are opposites, and therefore this should create a mirror image with a line of symmetry, and 0 would be my line of symmetry. So I'm going to substitute in here. I have -2 squared, that makes a +4. I have -1 squared, that makes a +1. I have 0 squared, which makes 0. I have 1 squared, which makes 1, and I have 2 squared, which makes 4. Okay, when this comes out, you can see they're the same. So now I'm going to go ahead and graph. So my first point is -2, 1, 2, +4. 1, 2, 3, 4. My next point is -1, +1. Then I have 0, 0, +1, +1, +2, +4. So I have my points that look like this. Now, because this is nonlinear, I am sketching the graph, which means I'm not using a straight edge because I can't, because it's not a straight line. So you're going to do your best job possible to connect all the points. Okay, and then there should be some arrows on the end because this is going to continue on. You can see my line is not the greatest. It's okay. Just do the best you can. So it's going to look something like this. now I have gone ahead and I have made my function table. I've graphed it. I would be done with this problem. Okay. One other thing I want to touch on really quickly is the example here. This is a negative x squared. So I want to remind you all that the exponent is only used on what it's touching. And what that means is that here the -2 is touching the x. I'm sorry, I don't know why I said -2. I just heard myself after the fact. Let me try that again. The 2 is touching the x. That means the only thing that is being squared is the x. So if I was to rewrite this, this is really -1 times x squared. This is the coefficient. The negative is the coefficient. You're not necessarily squaring a negative unless your x value is a negative. That negative is separate from the x squared. So that's important to keep in mind. So that is basically quadratic functions in a nutshell.